Hey, let's talk about physics. Today we are learning about position versus time graphs, velocity versus time graphs, and acceleration versus time graphs. So let's dive right in. Make sure you know what a slope is, the rise over run. And then the second thing we want to make sure you know is what is a tangent line. It's a straight line that just touches the curve of the point. So each type of graph can actually tell us about the other two types, either by the slope or by the area in between the line or the curve and the axis. And it's pretty cool. We're going to be comparing three different types of graphs. The first is the position versus time graph. And from that, we can find the distance at any given time. We can find the average velocity from the slope, and we can find the instantaneous velocity from the slope of a tangent line to the curve at the point. The second type of graph we are going to compare is the velocity versus time graph. And from that, we can find the velocity at any given time, the average acceleration from the slope, and the displacement of the object, the area between the curve and the time axis. The third type of graph we are going to analyze and compare is the acceleration versus time graph. And from this, we can find, of course, the acceleration at any given time, and then also the velocity, which is the area between the curve and the time axis. We're now going to go over 7 quick examples, but before we do, I just want to make sure that you understand everything. So here's a very brief review. The slope of the position graph gives us the velocity from the velocity graph. The slope of velocity graph gives us the acceleration from the acceleration graph. And the area under the curve of the velocity graph is the displacement on the position graph. Okay, the first motion object, number 1, that we're going to compare is an object that is at rest. And it looks like from the top graph that it's just sitting there at about 6 meters from the origin, and its slope is 0 since it's just at 6 meters all the way across. So the velocity then is going to be 0 meters per second. Okay, so we look down the second graph and we can see that it's just 0. Everything's at 0 no matter what time it is. And then since the slope is 0 all the way along, since it's flat and just a straight line, the acceleration then is also 0, of course, and the area between the line and the x-axis is 0, so the displacement is 0 looking back at the prior graph. And then the acceleration is 0, so the area between the line and the x-axis is 0, so the velocity is 0. So motion graph number 2 comparison. This object is heading in a positive direction at a constant velocity, meaning the speed is just staying the same. It's not getting faster or slower. It's moving, and you see the line's moving up because it's going farther and farther. And the line is straight since it's at a constant velocity. It's not changing, speed, if you will. The slope is 1, so the velocity is 1. And then going down to the next one, the velocity is constant, and it's not increasing or decreasing, hence the slope is 0, and so then the acceleration is 0. And the area between the line and the axis equals the displacement of the object. All right, so then this third graph, acceleration is 0, since the velocity wasn't changing. And the area between the line and the axis is 0, since they're the same, and so there's 0 change in velocity. Okay, so motion graph comparison number 3. This object is going in a negative direction and at a constant velocity. Look at the top graph. It says the object is moving in a negative direction. It means it's going in the reverse. And that means that when it heads down on the position graph, that means it's heading in reverse. Okay? And at a constant velocity, that means the line is straight. So the velocity or the speed is not getting faster or slower. The velocity we see on the next graph is, of course, -1. The slope is 0 since there was no change in speed or anything. So the acceleration then is 0. And the area between the line and the axis is -1. So because it's below the x-axis, so it's negative. So the displacement is -1. And the negative means, again, that we're going backwards. Okay? And then looking at the third graph, the acceleration is 0, as we found. And since the area between the line and the axis is 0, the change in velocity is 0. So looking back at the prior graph. So motion graph comparison number 4, this object is heading in a positive direction. It's moving forward and it's increasing in velocity. So it means it's getting faster. So the top graph, it says the curve is heading upward and the object's heading in a positive forward direction since it's going up. But since the absolute value of the slope is increasing, the velocity is increasing. Okay, so the absolute value means how far are you from the x-axis. So if you're positive 9, you're 9 away. You're getting faster. If you're at negative 9, the absolute value of negative 9 is 9. So that means you're 9 away from the x-axis. So that means that you're getting faster. You're just going in the reverse direction. So I hope that's clear. It's kind of confusing. The more you'll start to get the hang of it. It's kind of like learning a new language. So since the absolute value of the slope is increasing, as you can see, the velocity is increasing. And since the curve is convex, the line on the velocity time graph will have a positive slope, since that curve means the slope is getting steeper and steeper. All right, so then looking at the velocity time graph, the line is above the x-axis, so the object is heading in a positive forward direction. The absolute value is increasing, so the velocity is increasing. The area between the line and the x-axis equals displacement of the object. And you need to do a little geometry there, right, of the triangle. So then the slope of the line is positive and constant here on this second graph. It's a straight line. That means that the acceleration graph is going to be positive with a 0 slope. And then we look at the acceleration versus time graph. The acceleration is positive with 0 slope, so the velocity is increasing at a steady rate. The area between the line and the x-axis equals the change in velocity. And as you can see, it's positive 1. So the graph above there, it was a positive. Now motion graph comparison number 5. An object is heading in a negative direction with a decreasing velocity, so slowing down. So the position versus time graph shows us that the curve is heading downward, and so the object is heading in a negative or backwards direction. And then since the absolute value of the slope is decreasing, the velocity is decreasing. And then since the curve is convex, facing upwards, the line on the velocity time graph has a positive slope. The velocity versus time graph, the line is below the x-axis, so the object is heading in a negative or backwards direction. The absolute value of the velocity is decreasing, so the velocity is decreasing. The area between the line and the x-axis equals the displacement of the object, and the slope of the line is positive and constant, so the line on the acceleration time graph is positive with a 0 slope. So now here, this gets kind of confusing when you're heading backwards, slowing down. The acceleration is actually positive. The object is slowing down, but it's heading in a negative direction. So the acceleration is actually positive, even though the velocity is decreasing. And then the area between the line and the x-axis equals the velocity of the object. Okay, motion graph comparison number 6, heading in a positive direction with decreasing velocity. In the position versus time graph, we see that since the curve is heading upward, the object is heading in a positive forward direction. Since the absolute value of the curve is decreasing, the velocity is decreasing. And since the curve is concave, we're headed, like that, the line on the velocity time graph has a negative slope. Okay, so then we head on down to the velocity versus time graph, and since the line is above the x-axis, the object is heading in a positive or forward direction. Absolute value of the velocity is decreasing, so the velocity is decreasing. The area between the line and the x-axis equals the displacement of the object, and the slope of the line is negative and constant, so the line on the acceleration time graph is negative with 0 slope. Okay? And then going down to the acceleration versus time graph, the acceleration is negative with 0 slope, so the velocity is decreasing at a steady rate, and the area between the curve and the x-axis equals the change in velocity. Okay, and lastly, we have the motion graphs comparison number 7. Object heading in a negative direction, but with increasing velocity, speeding up. So the position versus time graph, since the curve is heading downward, the object is heading in a negative or backward direction. Since the absolute value of the slope is increasing, the velocity is increasing. And since the curve is concave, or like that, the line on the velocity time graph is going to have a negative slope. Now looking at the velocity versus time graph, the line is below the x-axis, so the object is heading in a negative backward direction. The absolute value of velocity is increasing, so the velocity is increasing. The area between the line and the x-axis equals the displacement of the object, and the slope of the line is negative and constant, so the line on the acceleration time graph is going to be negative with a 0 slope. And then going down to the acceleration versus time graph, the acceleration is negative with zero slope, so the velocity is increasing at a steady rate. And the area between the curve and the x-axis equals the change in velocity.